Hi students. Almost done. Lesson 16, video part I. There's only 2 more to go. Hang in there. We're making good progress. Like I said before, confidence intervals can be used to run a hypothesis test. Okay? They're built from the same ideas. I believe there is a subscript in the notes or a little footnote there. Close enough so that we really won't ever know the difference. Okay? Remember, when we cook up a confidence interval, we're using entirely sample data, so the p-hat shows up everywhere. When we run a hypothesis test, we're using that hypothesized value for the standard deviation. And so, for our purposes, close enough, we can come to the same conclusion using either one. And so this video is about those confidence intervals. You can view the values when you make a confidence interval, the lower boundary up to the upper boundary. This is a set of plausible values. So you can view the values inside a confidence interval as a set of plausible values for the true population parameter. In this unit, we're looking at proportions. So you can view it as a set of plausible values for the population proportion. Using that idea. Now, be careful. For number 1 here, what we're going to talk about for basically the rest of the page and possibly into the next for a little bit, we're thinking of two-tailed tests. And that alpha comes up. Remember, we're using that significance level alpha that Kim Shepard talked about in the last video. Significance level alpha. So with this method, we're using alpha when we run the test. You can test a two-tailed hypothesis test. P equals P sub 0 versus P not equals to P sub 0 at significance level alpha by computing the what? A confidence interval. What kind of confidence interval? It's the 1 minus alpha times 100%. Confidence interval. And so what are the 2 common alphas? Alpha 0.05, alpha 0.01. And think about this. If I take 1 minus 0.05, I'll be left with 0.95. And times 100%, so a 95% confidence interval for a two-tailed test is basically equivalent to running the test at alpha 0.05. And it comes up in the little bullet points there. So let's see what those have to say. If P sub 0, that's the number in your hypotheses, falls outside of the interval, reject the null hypothesis. I'll say it again, if P sub 0 falls outside of the interval, we'll reject the null hypothesis. It's easier with examples, and we'll get to one in just a minute. So let's think about this. If you compute a 95% confidence interval, it is effectively like running an alpha 0.05 hypothesis test. And we're in scenario number 1, two-tailed tests. Right? So just, I know it's set at the top, but this is a two-tailed not equals 2 test. Likewise, if you compute a 99% confidence interval, it is effectively like running what's left. Notice that these add up to 100%. If I express them both as percentages, then what's left here, this would be an alpha 0.01 hypothesis test. Not equals 2. Maybe for emphasis, pop that in there as well. We'll get to the one-tailed tests in just a bit. Okay, so here's an example about President Obama at the bottom of this page. And let's get to it. Back in November of 2013, Obama's approval rating stood at 41% based on a sample of 1,000 randomly selected adults. Make a 95% confidence interval for his approval rating by all U.S. adults. The data for this problem. Summarize the data. It's categorical. I have 1,000 answers probably in a computer, but just pretend on a clipboard. It's like approve, approve, disapprove, disapprove. More disapproves, right? It's only 41%. The data would be summarized as a p-hat. It's 41%, 0.41. Nice clean numbers this time. 1,000 adults were surveyed. I hope without a calculator we can figure out that this is about 410 must have said approve. Okay, so there's the data. Using the data, you know how to do a confidence interval at this point. So you should verify. Students should verify they can get this answer. Oh, we've got about 0.3795 up to 0.4405. Make sure you can get this. Soon you'll have to do it on quizzes and tests all by yourself, so it's a good time to pause the video and practice. All right, so it's probably a part B. Okay, let's run the test. So I'll flip over to the back side here, and I'll flip the slide. Based on the interval, part B, next page, test the null hypothesis that half of Americans approved the way he was handling the country at the time. In other words, this doesn't say fewer than 50%, more than, so we're looking for evidence that the true proportion differs from 50%. And what's the significance level of the test? All right, I'm going to run the test strictly with the confidence interval. Make a little bit of space here. We'll leave the interval at the bottom. Test the null hypothesis that half is 50%. So the hypotheses would be h sub 0 p equals 0.50, and h sub a, the alternative, p not equals 0.50. I can run this test without even doing the test statistic, getting a p-value. Look at the interval. Is the whole interval below 50%? It is. Is 50% in that interval? It's not. So, do I have evidence that P is not 50% for the whole country? Of course I do. If that interval captured 50%, doesn't matter where, then I would have no evidence to reject the null. But because the whole interval is below, I can reject the null and conclude the alternative. All right, so here we go. Run the test. Pretty easy. Reject the null. Whole interval is below 50%. Now, what can we conclude, students? Because we ran a two-tailed test, we have to be a little bit technical and official. I can conclude that, yes, there is evidence that the percentage of all Americans who approve the way that Obama is running the country differs from 50%. But what's the data telling us? Like in your head, you're thinking, well, clearly it's fewer than 50%, right? The whole interval is way below half. So it's a technicality when we start with a not equals to test. You're supposed to think of the conclusion in terms of not equals to or differs. Okay? Now, the last piece of this, what is the significance level of the test? A 95% confidence interval, CI, is the same as an alpha 0.05 not equals to test. A 95% confidence interval is the same as an alpha 0.05 test. So when we rejected the null, we did so at the alpha 0.05 level. Easy as that. Down at the bottom. one-tailed tests, greater than or less than tests. We can still test those at the using a confidence interval. The only thing is with the alpha level. At what alpha level would we be able to reject? Since we're only looking at the upper tail or the lower tail, I need to take the alpha and chop it in half because I'm not looking to both sides, I'm only looking up or down. You can test at significance level alpha divided by 2 for a one-tailed test. So alternative p less than p0, or if the problem says test for p greater than p0, by computing what? Well, the same confidence interval, right? It's got to be. It's written in your notes already, students. I've got to put it here though, right? I can run the 1 minus alpha times 100% confidence interval. Just remember when you're asked for the significance level, you got to take that alpha and chop it in half. So what's the chopped in half parts? Flip to those bullet points. Again, if p sub 0 falls outside the interval, we reject the null. If you compute a 95% confidence interval, the full alpha is 0.05, but we're only looking in one tail. This is effectively like running an alpha 0.025 test. It's half of the 5%, because we're only concerned with half the alpha. If you compute a 99% confidence interval, it's effectively like running the alpha is 0.01. I'm only looking in one tail, so half of 0.01. If I take 0.01 and chop it in half, I get 0.005. And I gotta squeeze this. This is right here. This is alpha 0.005. Careful with the decimals there, alpha 0.005, because we're only concerned with half of the alpha. All right, so looks like there is one final example. We'll check out these one-tailed tests using a confidence interval to run them. Rasmussen reports back in July of 2012, they said that 26% of Americans felt that their finances were getting better. This report was based on responses from 3,127 adults. Sample size, right? A statistician helped us out. They created a 95% confidence interval for the true proportion of Americans who felt that their finances were improving. And so using that data, we're sort of told a p-hat, there's a proportion there, we're told the sample size. Someone already calculated the interval for us, so there's less work for us to do. That's good. Can we conclude that more than 1/4 of all Americans feel they are improving their finances, and why? Now, of course, 1/4 is 0.25, and let's see. We're running the test here. I guess we're officially running the test down in B, but the confidence interval is like a pseudo-hypothesis test. Can I conclude that more than 1/4 of all Americans feel they're improving? Is 1/4 inside the interval? It is. Because the whole interval does not exceed 25%, statistically speaking, I cannot conclude that. The answer is no. Whole interval does not exceed 25%. Those are plausible values for the whole country of adults who think that their finances are improving. And so we're just looking, is it in or out? Can we conclude? No, we can't. All right. What would the hypotheses be? If you were going to run the test, well, translating the words into hypotheses is super important. We all need to be able to do that. And so H sub 0, H sub A. Personally, I always do the alternative first, at least in my head. I might not always write it down first. I'm looking for evidence of more than a quarter. More than says greater than, P greater than 0.25. At the introstat level, we always just default to equals to. So here are the hypotheses. P equals 0.25 and P greater than 0.25. All right. Wish I would have wrote that a little bit lower, but whatever. Part C, to wrap up this video, what is the significance level of the test if we use our 95% confidence interval to make the conclusion? And what would that conclusion be? Rewrite these hypotheses here. P equals 0.25 versus greater than. We already cooked up a 95% confidence interval. 95% confidence has alpha 0.05 in the tails. I'm only running a one-tailed test, so I've got to chop it in half. For this test, alpha is 0.025 because it's a right-tailed test. And what are we going to do? We're going to fail to reject, right? The interval, which would be helpful if it was on the slide, but I can get it for us. We've already made the conclusion anyways, but up here at the top, this interval was what? 24.46% up to 27.54%. And do I have evidence that P exceeds 25%? I don't. Fail to reject. Fail to reject HO, and this would be at the alpha 0.025 level. To write a concluding remark to wrap this up, what's the conclusion? I do not have evidence, right? There's no evidence that more than a quarter of all Americans think that their finances are improving. There is no evidence, in parentheses, at the alpha 0.025 level, because we are running a fixed alpha level test here. There's no evidence that more than 25% of all Americans think that their finances are improving. Pretty busy up here, but you've got the gist, right? There's no evidence at that alpha 0.025 level that more than 25% of all Americans think finances are improving. Remember, we failed to reject. When we fail to reject, we write the concluding remark like there's no evidence. If we would have rejected, we would start this by saying that there is evidence, okay? But not enough evidence to change our minds. And I do believe that's it. It is. Thanks for watching. See you in class.